and today we're going to be going over a medium LeetCode question. This question was sent out in our advanced problem set on our Discord channel, which if you guys are interested in joining, it'll be linked down below in the description. All right, the title of this question is Search in Rotated Sorted Array. It says that we're given an integer array nums that is sorted in ascending order with distinct values. What they mean by this is basically there's no repeating number inside the array. We're also given a variable called target that's set to an integer. Now they want us to suppose that nums is rotated at some pivot point that is unknown to us beforehand. So basically what this means, and a pretty good example of this is right here, is if we originally had an array that was just regularly sorted, as you can see right here, 0, 1, 2, 4, 5, 6, and 7, then once we rotate that array, it might become 4, 5, 6, 7, 0, 1, and 2. And now the pivot point here would be 7, because it goes from strictly increasing to, and then it decreases, and then it starts increasing again. So it goes 4, 5, 6, 7, and then after 7, drops down to 0. Then everything after 0 is increasing once again. All right, cool. Now, what this question wants us to do is to check if target is found in the array. If it is found in the array, then we want to return the index that it was found at. Otherwise, we just return -1. All right, so this is a pretty interesting question. Let's get to it. So I already wrote down a rotated sorted array right here, and also in a target. Now, the whole purpose of this video is to just go over one approach of solving this question. There's obviously multiple ways of solving it, but we're just going to be going over one optimal approach. So let's look at one approach first that it might not be as optimal. And that would be doing a linear scan on this array. A linear scan is basically just iterating through the array and checking every single element if it's equal to target. I'm going to be writing some pseudocode for the remainder of this video, but it should be easy enough to transfer it over to your preferred code. So let's iterate through this. Let's see how that linear scan might look like. We want to use a for loop to go through this array. Okay, there we go. Now the I in this for loop is going to represent the index of the array. So that means if the element in the array at index I, if that is equal to target, then what we want to do is just return the index that we found that target at. But now if we go through this whole array and we never found target, we want to just return -1 like the question told us. So right down here, we return -1. So this is not totally bad. Like I said, it's not optimal because the time complexity of this algorithm right here is going to be big O of n. This, like I said, this is not totally bad, but we could do better if we used a different algorithm. Now, what algorithm can help us with this? Well, as we read in the question, we know this is sorted, and whenever it tells us sorted, we want to think of binary search. So let me just write it down right here, binary search. Perfect. Now, what makes this algorithm so good is once we know for sure the array is sorted, we can use it, and then once we use it, its time complexity is going to turn out to be big O of log n, which is way better, way better than big O of n. Cool. So now that we know what algorithm we want to use, let's first see how binary search works. Now, to do that, let's just work on a sorted array, one that is not rotated, just so we can get the logic and the understanding of binary search down. So here we go. I already wrote down a sorted array right here with its indices in the bottom. And then our target, it's 7. So with binary search, we're always going to set a variable left equal to 0, and then right equal to the length of the array. Like that. You can call these variables whatever you want, but it's commonly called either L and R or left and right. Now let me just, so we can all visualize it. Left is set right here, where 0 is the index, and then array the length is also be, this is basically be equal to 5, which is be right down here. So R is going to be at the end. Awesome. Now in binary search, we're always going to be wanting to compute the midpoint between this left and right pointers. So when I say always, you guys already got a hint right there that we're going to be using some sort of loop. As you see later on, that loop is going to turn out to be a while loop. But let's just visualize it and do it as simple as possible first to get the logic done. So how do we compute this? Well, the midpoint is actually really simple. It's just going to be equal to left plus right divided by 2. In this case, left is equal to 0, and then right is equal to 5. If we were to divide this by 2, we would get 2.5, but we want to do integer division, which brings this down, brings this value down to just 2. Awesome. Now that we know that our midpoint is going to be right here, we want to do some sort of check. Now right there, as soon as I said check, you guys should have gotten another hint, which means we'll be using a if statement. What do we want this if statement to check? We want to check multiple things. First off, we want to check if the value that's at our midpoint, so the element at index 2, is it equal to target? In this case, our target is 7, but the element right here at the midpoint is 5. In that case, they are not equal to each other. So we know we have to carry on. If they were equal to each other, we would just return mid. We would just return 2, which is the index of that target, but it's not. So let's carry on. The next thing we want to check is that element greater than 7? If it was greater than 7, then we know that our values will be on the left. In this case, it's not. 5 is less than 7. Since 5 is less than 7, we know that 7 is to the right of index 2. So everything from index 2 to 5, well, actually we're not including 2, because we already checked if 5 is equal to 7, it's not. So a better way of saying this is everything to the right, which includes 3 to 5, that's where our target is located. So since we know that we can move our left pointer from 0 to 3. We move that left pointer extremely simple. All we want to do is now our left is going to be equal to mid plus 1. So now our left pointer moves to 3. And now we compute the mid once again. Our mid is now going to change to 3 plus 5 divided by 2. This will be 8 divided by 2, which is going to be equal to 4. Now our mid is going to be here. Is the value at our midpoint, is it equal to our target? In this case it is. 7 is indeed equal to 7. So we just return mid, which is our index 4. And we get the answer right. This is the basic logic of how binary search works. Let me write binary search up here. Binary search, binary search logic. This is exactly what it is. We want to set our left to 0 and our right all the way to the end of the array. And then we find the mid, and we continue cutting this array in half until we find our value. If it's not there, we just return -1. Perfect. Now that we know how this logic operates, let's see how we can use this to solve that rotated sorted array problem. Now let me delete this algorithm down here, this linear scan. Cool. So just like always, we want to still initialize our left to be equal to 0, and then our right to be equal to the length of the array. And like I said, we're going to be using a while loop. But what condition does this while loop have? The condition we want it to have is that we want this while loop to run while our left pointer right here is less than or equal to our right pointer here. So it will look like this. While our left is less than or equal to our right. Perfect. Why do we want it to be less than or equal to? Well, because in that case, if there's less than, there's still elements in between it. Then if it's equal to, it might just be itself. It might be right on top of it, and it might have missed one. So that's just an extra edge case that we're solving by including the equal to sign. Perfect. Now, what do we have inside this while loop? Inside this while loop, we're calculating the mid, which, as we know, as we talked about, is just going to be equal to left plus right divided by 2. Perfect. So now we calculated the mid. But now that since we calculated the mid, we want to do our other checks now. There we go. What do those checks include? Well, it's like we talked about. We want to make sure that our midpoint, we want to check if our midpoint is equal to our target. And we do that with an if statement. If array of mid, if that is equal to our target, then we can just return mid, which is the index. Oh, sorry, I forgot the return keyword. Return mid. Perfect. But what if that's not the case? Well, we do another check. But this check is to be a little bit special. It's not going to be like a regular binary, like a regular sorted array. In this check, we want to see if our mid is greater than or equal to our left pointer, that element that's at index L. So we do nums of mid, not nums, that's what the problem array is called. If array of mid, if this is greater than or equal to array of left. Why are we doing this? Well, since this could be rotated, since it is rotating, we want to see if the mid is greater than our left. We know if it is greater than our left. Let me go over here. So let's say this is our mid right here, 7. Say mid is right here. Left right is right here. And then our right is right here. We want to check if our mid is greater than to our left. What's the whole purpose of this? This is checking if from left to mid, if it is sorted. We know if it's sorted, then we can do another simple if statements inside this. So let's go through that. So now we know, doing this check down here, if array of mid is greater than or equal to array of L, we're basically saying that from index L all the way to index mid, it is sorted. So whatever it is, what do we care about that? Since it's sorted, now we can do this. We can check if the array in the left is, if it's less than or equal to the target, and the target is less than array of mid. If this is the case, then we know the target is between or within the subarray, because the target is greater than or equal to 4, which that's where our left pointer is initialized, and it's also less than mid, so we know our target's somewhere within here. And then if that's the case, then we want to change what our right pointer is equal to. We want to change our right pointer to mid -1. What this is saying is we now change our right pointer, instead of being here, we're going to be moving it over here. Why are we not moving it here? Well, it's because we already checked if the element at this mid index is equal to the target, and it's not. Perfect. So that's what that's saying. But let's say that's not the case. Let's say this if statement doesn't get hit, and we know that it's not, we know that our target, it's not between left and mid. If that's the case, then we know our target, it's somewhere here. Let me change my color back to white. If it's not between here, then we know our target is going to be somewhere here. So what that means, instead of changing our right, we want to change our left pointer. So we'd use an else, left is equal to mid +1. Awesome. So now there's one more check we want to do. We already got all this logic down, these first two if statements, we got them down. But now there's another we want to check. What if this if statement and this if statement fails? So this doesn't get hit and this doesn't get hit. Let me first talk about when that could happen. So let me see if I can write it somewhere off to the side. I could, perfect. So let me actually do this Maybe do something like this, just so you guys know it's cut off or it's a different section. Cool. So when would this, we obviously know when this will fail, but when would this if statement fail? That will fail when the array has a special condition. That condition will be when the array, let's make it similar to the other one. Let's say the array is 4, 5, 6, 7, 0, 1, and 2. Now, this condition right here will fail when the pivot point is to the left of the mid. So let's say the mid is right here. And then of course our left is here. Now in this case, that would pass, because the element at mid is 7, which is greater than or equal to the array at element left. But if we had the pivot point on the left hand side, let's say we have something like 8, 0, 1, 2, 3, 4, then 5. Our mid, let's say our mid is 2 and our left is 8. This would not be the case. This would actually fail this if statement right here. This is how it would fail. This check is basically saying if this left hand subarray sorted, or it's fine, it's not been rotated, it's still strictly increased, it's sorted. That makes it a little bit easier for us. So that's how I could fail. Let me just delete all of this. right here. Perfect. Now let's go back to what we were working with as soon as I finish deleting all this. So now that we know when it could fail, we know we have to use another if statement for that. This if statement is actually pretty similar to what we have already seen. Let me change everything. So now if, actually, now the same we do if, let's just do an else. Else, I'm gonna give myself some more space. Else, if, now this is where we do something similar to right here. If the array, if the element at index mid, if that's less than target, and then target is less than or equal to array of right. Whoops, not parentheses. There we go, bracket. If this is the case, then what we want to change is our left pointer. We want to change our left pointer to left is equal to mid plus 1. Let's keep in mind that that array we talked about, that let me see if I can write up here to the side, that 8, 0, 1, 2, 3, 4, and 5. This is when this else statement block will get hit. If that's the case, let's say our mid was at 2. If mid was there, and let's say our target was 4, if our target is greater than mid, in this case it is, but it's less than or equal to the array, the element at right, which our right would be right here, then we want to change our left pointer to be equal to mid plus 1, change it to this 3. And that works. That works perfectly. So that's how we handle that edge case where the pivot point is to the left of mid. But just similar to this if statement up here, we want to add an else. What we want to do is else right is equal to mid minus 1. And this is just in case that our target does not meet this criteria. So perfect, we got our while loop and we got it done right, where if we ever do find a target inside the array, we return in mid. But what we want to do is we want to add something outside of this while loop. What if we never find the target inside the array? Well, that's where the return -1 comes into play. Now, if I were to zoom out, allow you guys to see the whole pseudocode, this is how it would look. And this is our answer to this question. Let's actually type it up. So let's go to the problem. Let's put this here to the side. And you guys will see that if we follow this directly, it would actually 100% work. So we want to initialize our left. I'm going to be doing this in Python, but you guys have the pseudocode right here, and it should work for your preferred language. Let's set our left is equal to 0, and then our right is equal to the length of nums minus 1. The reason why I'm doing -1 here is because in Python, it will give me, if this was our example array right here, this 4, 5, 6, 7, 0, 1, 2, 3, instead of giving me 7, it would actually give me 8. It doesn't start off at 0. So that's why I'm doing the -1, to make sure I'm not out of bound. So perfect, we initialized left and right. Now let's do our while loop. So while our left is less than or equal to our right, we want to run this loop. Let's first compute our mid. Our mid is going to be equal to left plus right divided by 2. Right here, I'm using 2 slashes to do integer division because we want to round it down. Perfect. Now let's add all of our if statements. If array of mid, actually nums, now I'm getting backwards, nice. If nums of mid is equal to target, so if the element at mid inside the nums array, if that's equal to the target, Well, let's just return mid. Now let's add our other if statements. Are if nums, whoops, if nums of mid is greater than or equal to array the elements in the left index of the array, or in the array called nums, keep on messing that up, then what we want to do is add one more if statement. If nums of left, if this is equal to or less than target, or if it's just less than nums in the mid index in nums, then we know we have to change our right pointer. This is basically saying the target it's between our midpoint mid and then our pointer left. So we want to do right is equal to mid minus 1. If that's not the case, then we know what we have to change is our left pointer is going to be equal to mid plus 1. Let me just make sure everything's the same for consistency. Perfect. But if this never gets hit, then that means that the pivot point was in that left subarray. So let's check for that using our else. Now we do the exact same thing. If nums of mid instead of left is now going to be mid, because we're going to be checking the right subarray. If that is equal to, if that's less than the target, and target is also less than or equal to the elements in the right, the elements at index R, then we know what we have to change is the left pointer. Because this is saying the target is between the mid index, and the right pointer index. Change that to mid plus 1. Else, we just do R is equal to mid minus 1. Okay, it's not in between. Since this fails, we know it's not in between that right subarray. So what we have to change instead of the left pointer is the right pointer. Perfect. And now if we never do find mid, all we have to do is just return -1. Let's see if this works. Perfect, and it does. And now let's submit it. And it works. There we go. So thank you guys for watching the video. Like I said, the Discord invite link is going to be down below in the description. Make sure to join it. We send out LeetCode problems for beginners and advanced users every single day. And thank you guys for watching the video.